everyone, students of Sec 3 and 4 AMF students. In today's lesson, we're going to talk about one of the most sought after tuition topic, which is logarithm. Okay, why is that so? Because this is definitely one of the pain point of all AMF students, regardless of whether you're secondary 3 or secondary 4. Somehow this is just not working out. But the problem with this topic is also that it is not just a Sec 3 topic. In fact, it is also a Sec 4 topic, because if you didn't learn well in Sec 3, then you will find that when you do Sec 4, under calculus, differentiation, integration, you continue to face problem when you need to work on it. Yeah. So let's take a look at these rules again. So this is meant as a review, and then we'll go through some questions together. So logarithm is, first thing first, when you learn, you actually learn about the rules of logarithm. So there's a total of, actually more than these three, but these three I think is the basic and fundamental. And sometimes you might actually confuse with the rules of how to do it. Especially this addition one will later confuse with the multiplication one. Okay, so log BMN, okay, the put together one is equals to log BM plus log BM plus log BN. So important thing is that the base must be the same. Correct? The base is the same. Then in this case, the thing that has been logged, namely M and N, will be able to put together or separate. The reason why I'm showing the separate one, because I think the put together one, most people don't have much problem. But the honest truth is that when we talk about a question, most of the time they like to test whether you know how to put them apart. So the separation becomes important as a result of that. So I show you the separation one. And of course, M over N, which is M divided by N, when you change it back into two separate log terms, same base as well, so it's also B and B, then you will get M, so log BM minus log BN. Okay, and then last but not least, you need to learn how to bring up the power or bring down the power. So in this case, we will have a term that has a power. So if you want to bring it down, then the Y will be carried forward. Okay, so but most of the time, in simplifying logarithm, you will be doing the opposite instead. So you want to bring it up before you can combine into a single log term. Okay, so this is an important thing. So this step will be before combining into a single log term. Please remember to do this. Bring it up. Okay, bring it up. So now with that, let's look at some of the questions where you have to do simplification. So at the top left-hand corner, I put a box with the things to remember. So I think sometimes we just put A and B, some people are confused. So what I did was I put a terms with number, so you can know, if let's say in real time I'm going to do this, what am I supposed to do? Yeah. So for log log A8 minus 2 log A4, if you recall the rule I said just now, which is, please remember to remove the coefficient in front of the log term. So in this case, 2. Okay, but you can leave the minus sign there, just bring up the 2. So as a result of that, this will become log A8 minus away log A4, then with a power 2 here. Okay, so now, according to the rule we learned previously, if the base is the same, which in this case is A, right? Both are A, this is A, this is A, then I will say that we can put them together now. So the rule says you have to take the things inside the logarithm to divide. So I will take 8 divided by 4 square. So just one log term, A. So this put a bracket, 8 over 4 square. Okay, then we will get log A, 8 divided by 16, which is then translated to log A simplified will become half. So you can either keep it this way, or if you prefer, you can also change it to log A 2 to the power of minus 1. This is negative index. Then after which you can bring the minus 1 in front. So it will be negative log A2. So it's totally your preference, but regardless of whether you put it as half or negative log A2, both are correct. Yeah, as a combined term. But in some cases, if let's say further simplification is possible, so we will not leave it as 8 over 16. So this is only thing to remember. But you leave it as log A half or log A to the power of minus 1 or the minus come forward, I think is generally still acceptable. Okay, let's look at the next example now. Simplification again, but in this case, we're going to use a special rule to help us. So there are a collection of special rules, and this one that we're looking at is one of it. So we have log AA equals to 1, which means to say that so long as the base and the thing you're trying to log is the same thing, the number is the same, then I can just simplify it to 1. So in this question, actually, I'm going to do the opposite, because in order to combine 4, ln 15 and ln 5, I need to make them the same log base term. So 4 itself doesn't have the log base term, but in this case, we can always add it on. So I will be changing this to 4 ln 1 minus ln 15 minus ln 5. Okay, so this is what I'm going to do. And ln 1, okay, ln 1 is basically, sorry, I repeat myself again. Actually, it should not be ln 1. Okay, let me do this again. So this should be 4 ln e. Okay, not ln 1, because ln 1 will be 0. I just realized. Okay, so it should be ln e, because ln is actually log base e. So log e will be equals to 1. Okay, so 4 ln e. And the reason of doing this is really because that I want to make sure that every term has the logarithm with the same base. So now if we're going to put them together, I'll be doing this first. So remember, bring up the power. So ln e4 minus ln 15 minus ln 5. So you can either do it together, or my preference is maybe we will do it separately, 2 terms at a time. So this will become ln e4 over 15 minus ln 5. Then after which you divide one more time, then you will get ln e4 over 15 times 5. Okay, then you can simplify this, and that will be the final answer. So 15 times 5 will be 75. So final answer would have been equals to ln e4 over 75, and this will be the final answer. So a simple log term. And what I did here was to use this log AA rule that we see here. Okay, log AA rule. And this log AA rule can help me to create the ln e term without it really happening there. Because we know that if I can simplify log AA to 1, I can also think of 1 as log AA, right? In the opposite direction. Okay, so this is the rule number 1. Rule number 2 is what I incorrectly showed just now, which is log A1. So log A1 is equal to 0. So long as you're going to log a 1, any base, you will find that it will always turn into 0. So now if you look at this question, the way that this question will normally lay out will be to make you think that, wow, this is a very complicated question. But in actual fact, it's not really that. Like we have a log base pi. What exactly is base pi? Should not have done it ever at all. But the thing is that you then notice that 1248, a very large number, is raised to the power of 0. So quick recap, anything to the power of 0 is always equal to 1. Okay, so this is what we're going to do for this question. So 3 minus log base pi 1. Then for the last term, if I want to simplify it at the same time, I could, because 9 is actually 3 squared. So this is log 3 squared. Okay, then remember the rule just now, we said that log AA is equals to 1. So this is what we're going to do here. So in sequence, okay, let's simplify the term in the middle first. So this becomes 3 minus 0, because log to any base of a 1 is always 0. Then for the last term, we're going to bring down the power. So 2 log 3. Okay, almost at the answer already. Finally, we will get 3 minus 2. Why? Because log 3 is 1. 2 times 1 is 2. So 3 minus 2, this will become 1. And this is the final answer. Okay, so the point on this question is really to help you to understand that no matter how funny the base is, like in this case it's a pi, never do it before, but not to worry, because 1248 to the power of 0 is 1. So log to any base with 1 is always just 0. Alright? Okay, now let's talk about the last thing that you need to know in logarithm. So those are related to the basic rule. this is the last basic rule called the change of base. This is usually used if the base is different. The limitation of the need to do this is really because that when we talk about the limitation of the multiplication and division, the combination rule, where we need to make sure it's the same base. So in this case, we need to learn this because sometimes we might be dealing with different bases. So according to this base, once again in school as well, you will find that it's always ABC, then well, what are they talking about? So I'm going to do one demonstration here in real time. Imagine you have log base 2, 3. Okay, log base 2, 3. Let's say I want to change to log base 10. If you remember, log base 10 is basically LG. So how do we do it? Okay, always remember the big number here will appear at the numerator. So now with the new base as base 10, we will put LG 3, then divided by, okay, the original base will now appear at the bottom. So the 2 will be here, this will be LG 2. So LG 3 over LG 2. Then from here, we can, okay, why I change the base 10, right? It's because from here, we can press our calculator. So you can press your calculator to evaluate this. In your calculator, there's only 2 expressions you can evaluate, either ln or LG. So one is base E, one is base 10. And you'll find this very useful because if you know how to change to log base E and base 10, then you will find that you can press your calculator from that point onwards. Okay? And one of the use of changing of base is this. Apart from combining and solving equation, we can actually also do cancellation or logarithm. So you look at this question, log 781 times log 310, 100 times log 79. So in this case, if we want to simplify this, then we have to do cancellation or logarithm. But once again, you can only do cancellation if the fraction has terms that is the same. So what we're going to do here is that we need to change all to the same base. Question is, which base? As I will always share in the class, it doesn't matter. Any base will do, so long as it's the same base. But of course, if you change to the wrong one, I mean when I say wrong, is one that is ending up with more tedious working that you need to do. But otherwise, actually you can change to any base that you want. So over here, what I'm going to try to do will be, I'm going to try to change everything to base 7 and then see what we get. So the first one, I'm not going to touch it. I'm going to write log 7. But one thing I'm going to do is, I'm going to change 81 to the lowest base with the power. So what I mean is that, right, I'm going to change it to 3 to the power of 4. Later, you will see why. Okay, then I'm going to multiply to log base 7, the new base. 100 will go on top. Then divided by log base 7, the 3 will go to the bottom. Okay, then log 49, this is base 10. I'm going to change to log base 7, 49 over log base 7, 10. Okay, this is what I'm going to have. And then following from here, I will simplify this. So first thing first, I'm going to bring down the power 4 to get log base 7, 3. Then multiplied by, once again, this will be log base 7. Instead of writing 100, I'm going to write a 10 square. Then divided by log base 7, 3. And last but not least, we will get log base 7, 7 square over log base 7, 10. Right? So the reason of why we need to change the big number inside to a lowest base with a certain power is because that I need to further simplify this. So now if you look at this diagonally across, we have a 4 log 7, 3 and log 7, 3 at the bottom. And this is really 4 times log 7, 3. So I'm going to do a cancellation now. Okay, then I can simplify it already. And even for the term in the middle, if I were to bring down the power 2, I will also be able to cancel this as well. So there's a 2 in front now. And I think we are almost done. For log 7, 7 square, if you bring down the power 2, then we can simplify it to just 2 times 1. So at the end of the day, we're going to get 4 times 2 times 2, the whole thing divided by 1. And the final answer will then be 16. Okay, so you can see how we can change the log terms all to the same base, and then eventually we can do cancellation. But take note, this only applies to logarithm term that's multiplied together. The term is multiplied, not the things inside is multiplied. So that's a different thing altogether. So if we have log 2, 3, okay, log 2, 3 plus log 2, 4, then this will become a log 2, 3 times 4. This is what I call the things inside that's being multiplied. But what we are seeing here is the entire logarithm term that's being multiplied. So it's a different thing altogether. Please remember, do not mix this up. Okay, and last but not least, we're going to talk about one of the last skill set, which is to solve a logarithm equation. So looking at this now, this question will probably require you to do a change of base. So let's try to change everything to base 4. So this will then become log base 4x over log base 4 2 minus log base 4 x plus 6 equals to 0. Some of you at this point might be a bit lost, like, how do I do the log base 4 2 part? Like, what can I do? Okay, this part will require you to understand something about indices now. So from here onward, log base 4x is in fact equals to log base 4, okay, 4 to the power of half minus log base 4 x plus 6 equals to 0. So you can see that 4 is 1 and 4 square root, which is 4 to the power of half, is really just 2. So I'm working backward. I will change 2 to 4 to the power of half. So then from here, I can then continue to get log base 4x divided by half minus log base 4x plus 6. Okay, if you divide by half, anything divided by half, you flip over the fraction, then it becomes multiplied by 2. So this is 2 log 4x minus log 4 x plus 6 equals to 0. And then from here onwards, I can use my logarithm law again. Bring out the power 2 first. Then in this case, I will get log 4, okay, x squared over x plus 6 equals to 0. Okay, then how do we continue from here? So one of the things that we mentioned just now was I can always change backward, not forward. So if I know that log of anything 1 is equal to 0, can I work backward now to change my 0 back to this? Okay, so instead of writing 0 on the right side, this will be log 4 x squared over x plus 6 equals to log 4 1. Okay, reason is because that the final endpoint of any equation solving should be the orange color box thing, which is both sides got the same log base. Now I can remove the log base to get x squared over x plus 6 equals to 1. And from here onward, this becomes a quadratic equation. You just need to cross multiply. Then, okay, right here, this will become x squared equals to x plus 6. Then you will get x squared minus x minus 6 equals to 0. So this becomes a quadratic equation where you just need to continue to solve it. Okay, so and of course, after you solve it, you still need to check, right? You still need to check. Okay, let me try to solve this now. Okay, let me write at the top. There's a bit no space already. So if I were to factorize this, I will get x squared minus x minus 6. So x 3, 2. Then this is a minus. So this will factorize into x minus 3, x plus 2 equals to 0. Okay, then we will get x equal to 3 or x equals to minus 2. Okay, where this has to be rejected. Why? Because if I were to put a minus 2 back into the equation, you will notice that log 2 negative 2 is undefined. Okay, so as one of the last steps when you solve a logarithm equation, please remember, check and put back the number back into the equation. Make sure it doesn't cause anything to be error or undefined. So it's not like we can accept all the solutions. You always need to make a check to make sure that the solution can be accepted by a logarithm term. Okay, I hope you like this video. So this is the video on logarithm. So I've talked about all the basic logarithm up to the point of solving the logarithm equation. In future video, I will probably talk about the trigonometry, which is the second most difficult topic across all Sec 3 and Sec 4 A Math. So please look forward to the next video where I talk about trigonometry. I hope this video is useful to you. If you like it, please help to subscribe and share with your friends. So if you come for our class, there will also be a good discount for you. Alright, okay, see you for the next video.